All right, let's get started with our polynomial division unit test. For the first question, what do we have? Select all the polynomials that have a factor x plus 2. Okay, so if x plus 2 is a factor of any polynomial, we know that if we insert x plus 2 equals 0, x equals minus 2, if we insert x equals to minus 2, um, on these polynomials, and their remainder should be 0. Okay, so this is the thing that we are going to check whether the remainder is 0 or not by plugging in values for x. So x cubed negative 3x squared, so I'm going to plug this one here. So x cubed, then we have negative 3x squared, negative 3x squared, negative 10x, negative 10x. Okay, so we want to plug in x equals to negative 2. So what I'm going to do is I'm going to remove all the x with p, and I'm going to set p as negative 2. P as negative 2 and see whether the remainder is 0 or not. There we go. The remainder is 0, so I have to choose A. X cubed plus 5x squared plus 4x. So plus, I select plus 5p squared plus 4p. So x cubed plus 5x squared plus 4x. So as we can see, the remainder is not 0, so b is not our answer. X cubed negative 2x squared. So negative 2x squared, negative 13x, negative 13x. Then we have negative 10. So negative 10. Remainder is 0, so we also select C. X cubed negative 6x squared. So negative 6x squared, positive 11x, positive 11x, and then negative 6. And this is not 0. So A and C is our answer for this question. The polynomial px equals this thing has a known factor of x plus 1. Rewrite px as a product of linear factors. All right. So we already know that x plus 1 is a factor. So what we can do is we can do long division with x plus 1, and we will find the quadratic factor for this cubic equation. So uh, the remainder, the quotient is 5x squared for the first thing, yeah. So now we have to multiply 5x squared with this thing. If we do so, what do we get? Let's say 5x cubed. Okay, 5x cubed negative, we have 5x cubed, we have negative 5x squared. Okay, 5x multiplied by x is 5x cubed, and sorry, not negative, positive 5x squared into 1. Now we subtract this, so this thing gets cancelled out. We are left with negative 9, negative 5, so negative 14x squared, negative 6x. Now the next remainder is negative 14x, and I multiply negative 14x with x is negative 14x squared, negative 14x, and if you subtract this from so what happens, this thing gets cancelled out. Positive 14 minus 6, it's 8x, and we also have this 8 from here, so positive 8. So now we want to select positive 8, so that 8 times x is x plus 8, the remainder is 0. So this is our quadratic factor, 5x squared negative 14x plus 8. Now we have to factorize this. Either we can use the middle term, we can use the quadratic formula, x equals to negative b plus minus root over b squared negative 4ac divided by 2a, where a is the coefficient of x squared b, the coefficient of x, and c being the constant. We just have to plug in values and we'll get the roots, and just whatever the value for root is, we just have to do the reverse process for finding the linear factors. Alternatively, what we can do is we can plug in the value in decimals. So 5x squared, we have negative 14x, and this is the easiest one, positive 8. So this is the quadratic equation we have, 5x squared negative 14x positive 8. So what do we get? We get uh, 0.8. So 0.8 is 4 by 5. 0.8 is 4 by 5. So we get x equals to 4 by 5 and x equals to 2. Okay. So if x equals 4 by 5 and x equals 2, then 5x minus 4 must be a factor and x minus 2 must be a factor. Okay. So 5x minus 4, 5x minus 4, and then we have x minus 2. So x minus 2, and this thing is the known factor, so we also put it here, x plus 1. So this should be our answer. Your answer should be in the form polynomial of x plus ko upon x minus 2, where p is a polynomial and k is an integer. We have to divide x minus 2 with, I have to divide x squared negative 3x positive 9 with x minus 2. So first thing is x, so x squared negative 2x. We subtract this, so this becomes positive. So negative 3x positive 2x becomes negative x positive 9. Then what do we get? We can select minus 1, so minus x minus minus plus 2. So if you subtract this, 9 minus 2 is 7. So we can write is q plus r by d, quotient plus remainder over divisor. So quotient is x minus 1 plus remainder is 7 upon x minus 2. So this will be q minus 1, sorry, x minus 1. Then we have plus 7 over x minus 2. All right, px is a polynomial. Px is divided by, when px is divided by this, the remainder, blah, 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 find the following values of x negative 3. So when this is the this is the remainder theorem. So when we insert negative 3, that is the same as dividing x plus dividing by x plus t. So we would get negative 4 here, as it is negative 4 here. And for inserting the value of x as 7 is equivalent to dividing by x minus 7, because we want to put equal 0 to the back bracket and see the value of x. So that's why this is negative x and not positive, negative 7 and positive 7. So negative 7 has a remainder of 9, so we would also get 9. All right, the polynomial p of x is a quadratic equation, has a known factor again, so we have to do the long division again. So we want to divide x minus, we want to divide 3x cubed negative 20x squared positive 37 of x negative 20 with x minus 4. So let's see, let's start with 3x squared. So what do we have? We have 3x cubed, because 3x squared multiplied by x is cubed. Negative 4 3 is a 12x squared. If we subtract this, this gets cancelled out. We have positive 12, so negative 20 positive 12 is negative 8x squared positive 37x. Okay, negative 20, then we have positive 12 is negative 8. So now what do? We use negative 8x, so negative 8x into x is negative 8x squared, and then negative positive 4 is a 32, so we say 32x. When we subtract, we are only left with 5x negative 20, so we could say we could take positive 5, so that 5x and 5 fours are 20 gives us the remainder of 0. So we have to just factorize this thing. 3x squared negative 8x plus 5. Okay, 3x squared negative 8x plus 5. Okay, 3x squared negative 8x plus 5. What do we have? We have 1 and this thing. What is that? I think it's, let me see, 1.667. I think it's 1 whole 2/3. So 1 whole 2/3. So 2/3. 1 whole 2/3. No, 1 is here. 1 plus 2/3. Okay. So what do we see? Yeah, this is the same as this. So 3, 2 ones are 3 plus 2, 5 by 3. 5 by 3 is the same as what we have gotten here. Yeah. So 5 by 3 is one factor, one root of this, and another root is 1. So x equals 1 and x equals 5 by 3. Okay, x equals 5 by 3 and x equals 1. So this means x minus 1 is a factor and 3x minus 5 is a factor. I take 3 here and 5 there. So 3x minus 5, 3x minus 5, x minus 1, 3x minus 5, x minus 1, and this x minus 4 is the product of linear factors, x minus 4. Select all the polynomials that are divisible by x plus 3. So we have to plug in negative 3 and see whether the remainder is 0 or not. So I'm going to denote x with p cubed plus 4p squared. So p cubed plus 4p squared and negative 9. P cubed plus 4p squared, negative 9, and we have to plug in p as negative 3 because we're dividing by x plus 3 and the remainder is 0, so a is our answer. Then we have x cubed negative x squared, so we just remove this with a negative, and negative 18, so negative 18 is not equal to 0, so no, b is not our answer. X cubed negative 6x negative 9, negative 6x, so we remove this thing, negative 9. P cubed negative 6x negative 9 is not 0, and x cubed positive 3x positive 3x plus 3. Okay, so only a is our answer because that gives us the remainder of 0. All right, question 7. Your answer should be in the form where p is a polynomial and k is an integer. You have to divide x squared plus 6x negative 4 with x minus 1. I take x, so x squared negative x. When we subtract, what we get negative positive. We have 7x negative 4. Also take 7, 7x negative 7. What is the remainder? We have positive 7 negative 4, 3 being the remainder. So quotient plus remainder over divisor. So quotient is x plus 7 plus 3 upon x minus 1. So x plus 7 plus 3 upon x minus 1. Polynomial p is graph. What is the remainder when px is divided by x negative 3? So we have to plug in x3 and see what is the value. It is 1. So there you go. As we can see, we just have to plug in the value that we get after putting this bracket equal to 0. So that means x minus 3 equals 0. So what do we have? We have x equals to 3, right? So when x equals to 3, as you can see from the graph, y is 1, which is px. Select all the polynomials that are divisible by x minus 1. Again, we have to plug in 1 this time. So select 1. And what do we have? 3x cubed plus 2x squared. 3x cubed plus 2x squared negative x. So we write negative p, and the remainder is not 0. So no, 5x cubed negative 4x. 5x cubed negative 4x squared negative x. Yes, 0. So this is our answer. 2x cubed negative 3x squared negative 3x squared positive 2x positive 2x negative 1. It is 0. So C is our answer. X cubed plus 2x squared x cubed plus 2x squared plus 3x plus 2 is not 0. So B and C are. For the last one, the polynomial has a known factor, this thing. So what is the product of linear factors? So we know that x plus 3 is a factor. So 2x cubed negative x squared negative 25x negative 12. So I select 2x squared. So this is 2x cubed, and plus 3 to the 6x squared. When we subtract, this thing's cancel. Negative 6 negative x squared is negative 7 x squared negative 25x. We have negative 7x here, so that means negative 7x squared 21x. So when we subtract this, what do we get? We get positive 21, so negative 4x negative 12. I can select negative 4 here, so that negative 4x negative 12 gives us a remainder 0. So 2x squared negative 7x negative 4. 2x squared negative 7x negative 4 gives us 4 and negative half. So x equals 4 and x equals negative half. I can write this like this. Okay, so that means 2x positive 1, x minus 4 are the factors. So 2x positive 1, x minus 4, and we have x plus 3, the known factor. So this is our answer.